My name is Ian. I'm currently a sophomore at Harvard College, and I'm from Kenya. I study electrical engineering, and one of the classes I took this semester was PS70. PS70 is primarily a design class, and you learn a lot of digital fabrication skills. At the end of the semester, we are required to make a final project which uses most of the skills we learned in class. And because I love cycling and I cycle almost every on campus, I got a lot of inspiration from that, and that's where I got the idea of this final project. So my final project is split into two. They are both bicycle systems, but one is a lighting system and the other one is a speed sensing system. The lighting system is more for safety. I would normally use hand signals when I need to turn, and I wanted to make this easier for myself. So I'll be using NeoPixels and ESP32 to code the NeoPixels and a button, so I can just press a button to indicate the turn signals the way you would in a car. And I'm also using a photoresistor for ambient lighting. So during the day, the idea is that the your pixels will be brighter, so it's easier to see them. And during the night, because you don't really need a lot of light to be visible, the then your pixels will be dimmer.
Oh, okay. What about you? Oh, just for your speed. Oh, yeah. So generational. Yeah, that's my mentality too. I just need to get it done. It's just a lot of small things. Hate it. Motivation is yeah. So, yeah, yours has the most moving parts. How are you doing? What I was going to say is, how are you? Do you have a
The second system was the speed sensing system, and for this system, I just used the Hall effect sensors to track how fast my bicycle is moving. Hall effect sensors use can sense a magnet, and in the model I used for presentation, I have two wheels cut by laser cutter, and they have magnets attached to the ends. And then I have Hall effect sensors very close to where the wheel passes by. So every time the wheel passes by, it's recorded as an instance of the magnet, and every instance counts as a circumference. I also store values of the time when these instances are recorded and use that to calculate speed. I also record the highest speed recorded during the entire ride, and I also accumulate the distance covered by just adding the circumference to the counters every time the magnet is detected. This varies with speed. I'm using a power supply source from class here to show you how the speed varies when you increase the voltage of the motors. But ideally it's supposed to work the same in a bicycle when you speed up and when you slow down. I also included an additional display thing on the OLED where you can see either whether if you are riding or if you're stopped, if you're actively riding and the magnet is being constantly detected, the status is riding, and if you have stopped and the magnet is not being detected anymore, the status is stopped. At the end of the ride, you have the option to reset all your stats, or you can continue accumulating them. So yeah, that's my project in a nutshell, the lighting system and the speed sensing system. For more detailed explanation of how I made this possible, look up my documentation page. Thank you.
I'll bring the cows Yeah.